Let's look at our last example of arc length. So I want you to find the arc length of the graph of y minus 1 cubed equals x squared on the interval 0 to 8 as shown. So I'm going to provide you a graph here of the part we're calculating the arc length of. Now if you want to, you could graph that function. Let's see, 0 starts at this point 0, 1, and it goes up to 8, 5, kind of like this. Okay. So the first thing we're going to do if we look at our equation here is we're going to take it, and it doesn't say y equals, so we're going to solve for y. That's going to be our first step. So let's solve for y. Take our equation, and I'm going to take the cube root of both sides, so I'll get y minus 1 equals x to the 2/3 power, and then add 1 to the other side. 2/3 plus 1, and here's our equation. And now I need the derivative of this equation. Because I need it for my formula. 2/3 x to the negative 1/3. And now we've got a little bit of a problem. So if you look, this right here it's undefined when x equals 0. And x equals 0 is part of our interval. So that means this isn't going to work. And so we need to do something else. So what we should do instead is we should solve for x in terms of y. So take our equation and take the square root of both sides, and you get plus or minus y minus 1 cubed. And we're going to choose, right here, we're going to choose the positive one. And we're going to compute this derivative, dx dy. Oh, sorry, we took the square root, so this should be 3/2 power. Dx dy will be 3/2 y minus 1 to the 1/2. And now we're ready, now that we have our derivative, we're ready to plug into our arc length, s. It's the integral. So let's just write our formula first down. We're going to integrate in terms of y, so it'll be c to d, 1 plus dx dy squared dy. The integral, the square root, 1 plus 3/2 y minus 1 to the 1/2 squared dy. And to get the bounds on the integral, you're going to have to go back to the graph. Look at my range of y values. Y went from 1 to 5. Okay, so the integral from 1 to 5. And let's simplify this 1 plus. we're going to square 3/2, so we get 9/4. And now we square this, so the square root goes away, and it's just going to become a y minus 1. So I'm going to combine, I have two constants. I have 1 and a negative 9/4 because of that distributing. So it's the square root of 9/4 y minus 5/4. So let's go ahead and pull out a 1/4. And if we take the square root of 1/4, we get 1/2. 1/2, and I'll pull it out to the front. Square root 9y minus 5 dy. And now we need to compute this integral. Luckily, it's pretty simple, so we can just use u substitution here. My u would be 9y minus 5. So I'm going to put in, this will become, I need a 1/9, and I'll get u to the 1/2. And we're going to have to change our bounds in our integral. So when y is 1, I use this formula here to get u would be 4. When y is 5, u would be 40. So you're going to get 1/18. Do your reverse power rule. U to the 3/2 over 3/2. And if I simplify my denominator, it would be 1/27. Plug in top minus bottom, 1/27, 40 to the 3/2 minus 4 to the 3/2, and there is your arc length. So one final comment I want to make is that if you look at all of our examples, all of our answers were positive. Arc length is a distance measurement. It should always be positive. If you are getting a negative number for some reason, then something went wrong, because these are distance measurements. They should be positive.